let's move on to this thing. You're going to need a calculator again today. It's going to be kind of going over the same stuff as yesterday, except there's maybe slightly different questions to consider. Oh, batteries are low. Okay. So here we have Mr. Lowry's honors pre-cal exam. It was very difficult, he says. And so we want to find the mean and standard deviation for this. So I'll let you do it. I'll do it too. You want to get it in here so that when we start doing stuff to the data, you'll have it in front of you also. So type it all in. It's a lot of grades. Okay, so I got it all typed in, and then we're just going to go to one var stat, but I'll wait a second just to make sure you get there. Hey, Rajan, I'm beside you. Anybody else cut in when I was freaking out? My computer was freaking out. Nope, I think I said hi to everybody. Oh, and I said, so I noticed Nathan. Big fan. So we have stat, calculate, one var stat. L1, hit the old enter. And don't forget, if you do have the capacity to have a camera on, it really helps Pfeiffer stay motivated because he feels like he's talking to people instead of a blank screen. If it messes with your internet, I totally understand that, and you don't have to worry about it. So our mean, I don't know, I scroll down. Our mean here is 66.84. That's not the best average, but that's okay. And our standard deviation is 13.976. And yesterday in the video, I mentioned that there are two different standard deviations. Make sure you're aware of why we're using sigma here, sigma of x, instead of s of x. This is all the people in his class, so this is a population, so we're going to use sigma. And if I do anything where you're like, how did you get that? This is a great time to ask. Okay, so after receiving some input from students, he is considering 3 different options for curving. He's going to curve. It's really nice of him. We're going to predict what those options will do to the mean and standard deviation. So it says add 10 points to each student's score. Hopefully you realize that that would be, we'll call this mu A. That would be 76.84. And the standard deviation in this situation would still stay the same, because when you add, it only affects the mean. On to option B, it says increase every student's score by 10%. And what you want to remember about that, if you have forgotten from Algebra 2, is this is going to be a multiple of 1.10. That's how you do a 10% increase. So we'll call this mu B, and I should have left a little bit more space, but that's okay. So that's going to be 76.84. No. 66.84, the original, times 1.1. And that gives us 73.524. Sigma would also be affected. So sigma is going to also be multiplied, the original one, by that 110%, giving us a 15.376. 15.3736. And then the last one, and the order is important here. It says he's going to increase by 6% and then add 6 points. So we need to do it first with the 6%, which affects both, and then add the 6, which only will affect the mean. So the mean is going to be the 66.84 original. To increase it by 6%, we're going to multiply by 1.06. That'd be a 70.8504. And then we're going to add 6 points. So that'd be a 76.8504. A lot of fun numbers today. 76.8504. And then sigma of C, again, the standard deviation would only be affected by the multiplication, that 6% increase. So we're going to do 13.976 times 1.06. And that's our new standard deviation. That's the new spread of the data. So 14.81, let's say 5. And yesterday, and then we'll do it for just A. I feel like if you understand how we do it for A, you'll be set on all the rest. We're gonna, instead of using our prediction, which is, these are correct, we're gonna actually do it with our calculator. And so this is, I hope you typed it in just so you can see how this works. This is a useful skill. You're gonna go to Stat, Edit, and we're gonna go to List 2. This is a way you can transform your data in your calculator. So you can tell your calculator, hey, please take L1, and you get that by hitting second 1. Take L1, please, and we're going to add 10 points to everybody's score. So L1 plus 10. You have to make sure you're at the very top. If you get an error, it's because you were not at the very top of the list. So L1 plus 10. And that's these guys right here. And if you go to Stat, Calculate, 1var Stat, change that to an L2, because you're looking at the second list, we should, as a result of this, get what our prediction was. And so I see a 76.84, which is what we got before, 76.84. And our standard deviation does stay the same at 13.976. So make sure you are aware of how to do that in the calculator. Go to Stat, Edit, and then you can affect different lists. It's kind of like Excel or Google Sheets if you use that. And we will use this occasionally throughout the year, so it's a good skill to build up. Okay, so it says, based on the results, which option would the students prefer that Mr. Lowry use? And maybe this is a little bit subjective, but like looking through these, let's see if you guys can maybe identify which option would you prefer for your curve. Would you prefer A, B, or C? I'll wait a couple seconds for any interaction from you, which would be fantastic. Would you prefer A, B, or C? I can live in this awkward silence. I'm okay with it. All right, okay. Evelyn says C. Nathan says A. So I would agree. You guys have chosen the two that I would prefer, definitely over B. That one has the lowest average, and it also has a high standard deviation. So that means, yeah, you could go up to like 88 maybe, but you could also go far down because it's plus or minus that 15. So let's look at the difference between A and C. So both of them have similar means. That's true. And then they have different standard deviations. And both of you could be totally right. Like there's not like a preferred thing here. Evelyn's means that she might have a higher chance of, like if you were on the upper end, this would push you further forward maybe. And so then you would presumably, if you had a high score to begin with, you will end up with a higher score. This one's a little bit more consistent. So if you were on the lower end, this might be the most beneficial one. Not that Nathan would be on the lower end. I feel like you'd also be on the upper end. But either of those would be fine. You guys can write either explanation you want there. So I would go, let's go with, as a teacher, maybe I'd want to go with A, just so there's less variability with my data. But it's up to you guys between those two. I feel like B would be the worst choice as a student. So I would say choice A seems ideal. It has a low average, or so it has the second highest average, but very close to C. So it has high average compared to method B. And it's similar to C. And lower deviation. So tests are closer together. Now again, this method is going to benefit you if you're on the upper end more than this one. Like this, you have a chance of being further away from the mean in the positive direction, you also have a chance of being further away from the mean in the left direction. So this is really totally up to you. This is a kind of a, I would say, we call it opinion-based answer. So it says, why did the 10-point increase have a different effect on the mean standard deviation than the 10% increase? Well, we already know that the mean's only affected, or sorry, the mean's affected by addition, affected by both addition, multiplication, but the standard deviation is only affected by multiplication. Is it affected? Whoops, affected. And then it says, write linear equation rules that describes the transformation, let y be the transform value, etc. And so what I'm going to do is I'm just going to do the first one. So this would be y is equal to x plus 10. That is what we did to the data. We added 10 to each of the data points, and that's how we got y. And I'll let you guys fill these other ones in based on what we would have done to the data. So like 6% increase and then add 6. So I'll just going to circle that and keep kind of going. So I think I need to talk you through that. Now we have Mr. Curry, and he suggests a different curve for Mr. Lowry. He has used the curve 50% of x plus 50 in the past, since it guarantees the highest score possible was 100. I think I've used that curve before. What would be the mean standard deviation for the test scores under that? I'll give you a second. Why don't you guys try to get that? I'll get it as well. Again, you want to try to be active. This is different than that box plot unit in that we're going to keep kind of progressing forward. And if you're not practicing, I feel like you will get left behind. The box plot unit might have lulled a couple of you into like a false sense of security. I don't think it's going to get much difficult or much more difficult or anything like that, but you do need to be practicing again because it's not the same thing as the box plot unit, where it was like every day was lower fence, upper fence, 5-number summary, yada, 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 done. I'm going to get my 2 answers, and hopefully you're getting your 2 answers, so we can look at those and make sure you're on the same page as me. Okay, so I did 50% times the original mean plus 50 would give us this for an average. And then, oops, and I have made a cardinal error here. 50% times the standard deviation gives us that. Ignore that middle thing, please. Sorry. So 83.42. And then the nice thing here is that the standard deviation is going to go down. This has effectively squished all the data. Everybody's going to be very close together because of the lower deviation, higher mean. So this seems like a pretty good situation for the students. Then let's finally look at this one, which is a 1.3% increase, so a 30% increase, and then subtract 12. So once you guys find that, I'll find it as well, based off the original data. And so this is what I got. So the average would be about where the other ones were, near method A and method B. So 74.892. And it has a very high standard deviation. And so it says all this curve results in a mean standard deviation similar to others. So similar to these other ones that we've looked at. It's not much crazier than those other methods. Mr. Lowry sees a serious problem with using this curve, this method of curving. And it says, what is that problem with his curve that he's discovered? And I'll pause for just a second, see if you guys can think of, relative to the other ones, what the problem might be with this. Let me think. And you might want to consider the original grades. So I'll pause here for just a second. So there's an issue with this that the other ones didn't necessarily have. Any ideas? Not sure. Okay. I'll tell you, like, I imagine the person that Lowry would be concerned with is this guy right there. That helps out. And it's probably not the biggest of issues. But with this method, it's possible that it's not possible. It would happen. This guy would go above 100. And I don't know if that bothers Mr. Lowry, but that might bother Mr. Lowry. The other methods, if you tried them out, like if you had 10 points, none of them would go above 100. If you, multiply or you add on 10% to everybody, none of them goes above 100. If you do 6% increase and add 6, none of them goes above 100. This one, no one goes above 100. This is the first one where one of the students would go above 100. If you do, 88 times 1.3, and then you subtract 12, he is a 102.4. I guess Mr. Lowry does not like that very much. Doesn't like people getting above 100. So with this method, a score above 100 occurs, and maybe Mr. Lowry doesn't like that. I don't know if I'd consider it a serious problem, but he does, and that's all that matters. All right, and so what I'm going to do is stop the video, I think. Stop.